Howdy once more, it's Tubalcain, and this is day 14, part 8 of the build on the STUART engine. And be sure and go back and watch those other many parts if you haven't seen them. But as I left off yesterday, I was making gaskets, and I made this one and said I wasn't going to show you, but I think I changed my mind again, my prerogative. Because perhaps some of you haven't seen how to make these small gaskets, not that it's any different than making big gaskets, but using gasket material here, supplied with the kit. That's from England, jointing they call it over there evidently. It's a rather thin paper that we're using for this because it's a small model, but I'll start by punching or forming a hole for this step. Now I have a set of gasket punches, but I'm going to do this in the milling machine using a sheet metal punch, and I'll show you why. See you over there. I'm at the Bridgeport, and I have two sets of these gasket punches, gasket maker's punches, and as luck would have it, every one of these half-inch punches is just dull as can be, and look at how beat up this thing is. So it's been around the block, and both sets have been around the block, so I decided not to use that, and I have a whole drawer of leather punches and hollow punches and arch punches, but I decided to go this route, which I've used many times before, and this is a complete set of punches for my large Whitney Jensen punch. They're sheet metal punches, but what I did, and I used to use this method at high school to make grading keys, if you know what I mean, for true-false questions and so on. But here, with the punch in the collet and the die carefully located in the vise, it just works great for punching. So let me use the correct paper here and quickly punch that hole. My hand in the way, I'm sure it is. And that's all there is to it. Now back to the bench. Nice clean hole. And of course this is the exact method that I use for putting the masking on this wheel. You saw that yesterday. You didn't see me do it, but you saw the masking on there. So simply by straddling the vise, just something to gently pound on, using my smallest Vaughan ball peen hammer. If I can keep my hands out of the way, I just tap right around it. And that cuts the paper to the exact dimensions and conformity of whatever the object is. You see what a nice job that does? So now I've got 6 holes to punch, and the way I'm going to do that, and I'm going to pound on my anvil. I know I'll get criticized every time I tap on my granite surface plate, even though the thing only cost $22. So I got a little counter bore there. And using the clearance size drill for these holes, and I forgot what that is, it's a number drill, but notice that I ground the end square, in other words I sharpened it. And by using my brass hammer, which will not really hurt the point, although I know somebody's going to gripe about that, I'll just punch all 6 of those like that, and it works slicker than a whistle. And so on. And then I like to index or mark this as a rear gasket and maybe a little witness mark on it. I don't know if it's necessary, depends on how accurate the other 6 holes are. And that's all there is to making these little gaskets. And now comes what I have been dreading, and probably the most difficult part in terms of layout and drilling are all of these steam ports. And if you look at this vertical engine here, which is the exact same configuration as our horizontal one, but you can see that there are 2 holes drilled from the top, or in our case from the side, and then there are 4 steam ports that will align with these holes as this oscillates. Now there's dimensions for it. There are 13/16 between centers, which is 13/32 radius, and they call for measuring 1/8 inch between the two holes. I'm going to do it by my favorite method, which is transferring. Let's look at the other drawing. And you can see in this drawing, again, 13/16 between them, 13/32 radius. And in this little view here, they show 1/8 of an inch between them. And the problem here is that there's so little room that they're drilling these holes at a bit of an angle, and it doesn't tell what the angle should be, and that would be to avoid drilling, well, should I say that if these two holes are drilled too close together, they will break into the pivoting hole. Make any sense to you? So this layout line is right on center with the pivot hole, and I carry that over to the end here also. And then we need a line here, which is about in the middle. That's kind of bagosh. Again, no dimensions, because I'm going to put my exhaust hole down here and my inlet hole down here, and then block one of these holes, and I'll talk more about that later on. But there'll have to be a hole drilled approximately where the pointer is to intersect with the top hole here. But let me show you first of all how I'm going to transfer those holes onto this piece. I made two tiny little transfer punches. That's 3/32 soft stock, cut to about the right length, or to the exact length I should say, and I just filed a point on it because they're only going to get used one time, and I've already made two of those, and there they are installed. You can see the points aren't that sharp. Perhaps I should make them a little sharper. And they are bottomed out, and can you see that they're a little bit above the surface? So let me assemble this. Now with the engine assembled, and remember those little transfer punches are in there, I'm just going to rotate it a few times and hoping that those little punches are scribing two small arcs. Also, for good measure, with the crank at the 6 o'clock position, I am tapping this, and then again with it in the 12 o'clock position, and I'm wondering if that will transfer those two holes. Now we'll take it apart and we'll have a look. You know, this worked out far better than I anticipated, as you will soon see here. Not only have I swung an arc, which doesn't show up so well on this one, but it sure does there, but I don't really care about the arc. I care about the 4 holes that I transferred, and see how nicely that worked. Now I set this dividers for 1/8 of an inch. And laying it on there, you can see that in reality they're a little farther apart than 1/8 of an inch, perhaps 5/32. So I'm going to center punch those a little deeper, and then they are ready to drill. But the other question now, can I get these transfer punches out of the holes, the blind holes? So I'm prepared to use a magnet, and it did. It came right out. And if that didn't work, I could have blown them out by compressed air through the other ports. I would suggest using that method. Over the years we made many little engines at the high school, and this is how I did it with the kids, because this is, even though the engines were smaller, this is a very intricate operation for high school boys. And now I'm going to punch those holes using my Brown and Dull punch. And I'll do that to all 4 holes. I have the little casting in the vise so it will remain rigid, and I have two hands free, and I have center punched a hole there. I got too many lines on the end. I hope that's not confusing you, but I'm not going to drill that hole. I've set the dividers for 1/8 of an inch, and I'm going to swing an arc in each direction like such, and then I will center punch. Got to put my glasses on. Right there and right there, and those are the two deep holes. Those will be 3 30-second holes. Then I'm going to make some change to those dimensions, and they have to be how deep? Well, all the way at least past these two holes. So in other words, they'll be about that deep where my thumbnail is, and boy, I can see I need to cut my nails. They don't look so bad with the bare eye, but boy, when they're enlarged, it's looks like a pretty sloppy man that I am. So I've got 1, 2, 3, 4, 5, 6 very tense holes to drill. Now I've center punched the holes, so that's the one I'm going to drill first and then second, and I'm doing nothing with that center hole. That was just a layout hole. Again, 3 30-seconds. I'll do that on the milling machine. And do you understand now, as I loosen that up, that I do not want those two holes to break into the pivot hole, because then we would lose pressure or steam that would come out of that hole. And that's why I spaced those a little bit wider probably than necessary, and that these two holes here, or 4 holes, will be drilled at slight angles. If I look at it from this way, a bit of an angle, not that much, until they intersect with the other holes. And I'm going to do that on the Bridgeport. And you know, this was all done on crude machinery 100 years ago. It's amazing that men had the patience and the talent and precision to do that without ruining their little castings. I got to take just a little break here from what I've been talking about, because this was kind of tense. And you know, I was using these tap wrenches a little bit earlier, and AVE did a little video on these STUART tap wrenches, the straight handled ones, and they make 4 or 5 models. Actually, they make 4 models of this and 1 model of this particular one, and there it is in the original box. And as AVE announced, they are just absolutely beautiful tools, and I've had these for quite a while. These are the 2 smallest of the series, and it even tells you on here what capacity is, up to a 1/4 inch. You wouldn't need such a small one for a 1/4 inch, but aren't they elegantly designed and executed? It's just gorgeous tools. I know that's a little bit off topic, but I had to have a break here. And sometimes when I use tools like this, I think about that, like, boy, what kind of men made these and designed these, and they cost a fortune, admittedly, but you get what you pay for. Mine were used, of course. Brown and Sharp made an attempt at that, but it sure isn't as pretty. Sometime in my travels, I came across this, probably in an old toolbox, so someone had attempted to make one with approximate same design, and not too bad a job, and I had considered making one of these as a project, and I might still do it. However, the difficulty is to make that odd-shaped hole. I'm sure they had a broach to do that at the factory, but I don't have a broach. I did make, in the school shop, hundreds of these based on this model, and the kids filed that V in there, but it was most difficult for them, and it came out different on both sides. It might have looked good on the one side, and then you came to the back side and it was really botched up. So I know it wasn't easy for the kids to make that. Okay, enough of that off-topic nonsense, and let's get back to the business at hand. Well, I've just lined up that first hole using the wiggler, But take a look at my setup here. I use this aluminum block here simply to give a little more rigidity, but my work is squared up using a little stirred square. Then I clamped it onto this, so I'm vertical in both directions. I'm on the center punch mark, and I'm now ready to center drill, and then I will drill 3 30 seconds all the way down here, and I'll show you that in the next step here. So one step at a time. And center drill. Notice how I'm setting my depth stop. Visually I can see that I'm below that center punch mark. The stop is set. Then I can raise this back up, and then using my digital readout quickly return to my position of 0, and then I'm ready to drill. Overshot it a little bit. And it's quite a deep hole. So on a deep hole, I do woodpecker drilling to clear my chips. The powdered chips come out real nice even without a lubricant. I don't want to break a drill bit or a tool at this point of the game. Boy, that is a deep hole. And the hole that I'm drilling now is actually the exhaust passage. Now I'm drilling so deep that I think I'm going to go beyond the flutes of the drill bit, so it's even more important that I clear the chips or they have no way of escaping. Taking my time, which makes for a long video though. And now I will move over and drill the other one. I won't show that because it's identical to the one I just did. And I'm just about to depth with the second hole, and I am. But I'm not quite done here. And I took about a 7-minute break here to make this little brass pipe with a 3/32 hole in it and a 1032 thread on it. And since this is the inlet port that I just drilled, I'm going to go ahead at this time and drill it as long as the setup is made. The tap drill size for the 1032, and then I've got a little green line on here already regarding the depth, so that will be done all in one setup. I won't show that. I won't show the threading of it either because that's kind of routine, but that'll allow me to thread this inlet pipe into there. I forgot to tell you in an earlier part of the video, when I made these little transfer punches, I held them in a pin vise. That's a pin vise. First time I ever used it, but it sure is handy for those small pieces. Why am I telling you that? Well, because I just picked this up, and I will use that as the plug to plug this hole, the top hole, permanently. Then I'll grind that off. I'll put it in there with Loctite. Now here's the little inlet job that I just did. Now I'm ready to drill these holes, and I've determined that they have to be drilled at a 15-degree angle. So I'll spot them just a little bit in my camera-on drills so that when I start drilling at an angle, the bit doesn't skate off. But I'm going to do that angular drilling over in the Bridgeport in a tilting vise. I changed my mind. I'm going to drill these angled holes on the drill press here. This is my setup. the little Craftsman vise set at 15 degrees. That's the 3/32 bit. And I'm just going to drill until I feel the drill break through and intersect with the other holes. And there it is, I can feel it break through. And last but not least, one final hole right here. I've already laid it out and spotted it. And I'm going to drill that 5/32. That will be the exhaust hole, because remember, I'm going to plug up the one right on the end here. But the exhaust could be anywhere. Could be out here, anywhere along here, as long as it intersects with that port. That's not critical at all. And I probably will Loctite the little exhaust in there like a Mack truck. I think I said before, a little Mack truck. I'll make it brass also. And I'm drilling this in again until I feel it intersect with the other hole. That's the nice thing about a sensitive drill press. You can feel it intersect, and there it is already. You feel it break through, I mean. That's it. I've got the drill bits stuck in there simply so you can see the angle at which those ports are drilled, and remember that's the inlet here and the outlet or exhaust, and I'll plug this up, and you know what, it's almost ready to make a test run. I'll gently clean this up to make sure that it's clean, there's no burrs. Also, if necessary, a fella could put this on a emery cloth or whatever, you know, and lap it in. But I think it looks pretty good the way it is. I've got Loctite on this little plug here, so I can't even attempt to run it now. And anyway, that's quite enough excitement for today. So join me in the next part, which will be part 9, where hopefully I get it running and I take it apart and paint it, decorate it, and just wrap things up. And to complete this long video on building the little Progress engine. Thanks for watching, and I'll see you in the next part.